The world is made of two types of particles, fermions and bosons. This is just like the world is made of two types of people, those who can extrapolate from incomplete data. Physicists know there are only two types of particles because those are the only mathematical possibilities. Also, we thought until last week, because a team of physicists from Rice University in Texas says there's a third type of particle, the paraparticles. Let's have a look. Mathematics and physics are very closely linked, and it's a two-way relation. Sometimes math advances physics, and sometimes the other way round. One of the most amazing examples is, I think, the discovery of fermions, the particles that matter is made of. The fermions that matter is made of are characterized by having spin 1/2. This means it's a particle which has a direction associated with it like an arrow, but you need to turn it around twice for it to return to its original state. Imagine that the tip of the arrow goes around on a Mobius strip. If you go only 360 degrees, you're on the wrong side. You need to go around twice to return to the original position. If this sounds confusing, don't worry. Even the particle itself needs to do it twice to get it right. The thing is that if you ask mathematically, what are all the possible ways that particles can behave? You get particles that behave like normal arrows. You turn them 360 degrees and they're the same again. Those are called bosons. And then you get those that you need to turn around twice, which are the fermions. But the behavior of the fermions is not something that we see in our everyday life. Without using maths, physicists might never have come up with the idea. In the new paper, the authors now say that maths actually predicts a third type of particle. To see how this works, you need to know that the spin of a particle also tells you how the particles behave if you combine several of them. The bosons can do all the same thing at the same time, like they can all have the same energy or sit in the same place, for example. But fermions won't do that. Fermions will all do different things and space out. It's called the exclusion principle. Electrons are fermions, and the exclusion principle is, for example, the reason why they sit around atomic nuclei in different shells. In the new paper now, they take a wave function that describes multiple particles. The wave function is this psi, and then each of the axes here is for a particle. The wave function itself has complex values, but is not observable. We just use it to calculate probabilities by taking the absolute square. But the order in which these axes appear here has no physical meaning. You just pick this somehow. It's like you can pick whether Z is that direction or that direction. It's an arbitrary choice. So if you change the order of two of those entries, this shouldn't change anything observable. But since the wave function isn't observable, we can multiply it with some factor that has an absolute value of equal to 1, because that won't change probabilities. If we now swap these entries again, that creates another factor and gives back the wave function we started from. This means that the factor is either plus or minus 1. If you didn't understand the thing with the wave function, this is really the only thing that matters. In the end, there are only two options, plus or minus 1. If it's plus 1, then you're dealing with a boson. If it's minus 1, you're dealing with a fermion. It seems like there are no other options. The authors of the new paper say there's another way to do it. These wave functions might have multiple entries that they call modes. They're basically vectors. And then this vector here isn't a number, it's a matrix. Now we're looking for a matrix that squares to the identity, and there are many more ways to do this than plus and minus 1. This is what they call paraparticles. The idea itself isn't new, it dates back to the 1950s. However, until now, physicists thought that paraparticles can be taken apart into bosons and fermions again. The authors of the new paper prove that this isn't so. Instead, they say these are a genuinely new sort of particles, and they show that paraparticles can definitely exist as quasi-particles. Quasi-particles are not elementary, they're collective motions in some sort of material, like sound pulses. The authors of the new paper come up with an explicit example for how those paraparticles could be quasi-particles in materials with suitable interactions. This is interesting because the paraparticles neither fulfill the exclusion principle for fermions, nor can they all sit in the same place like bosons. They do something in between. Maybe that turns out to be useful for some technological applications. Even more interesting is that paraparticles could also exist as elementary particles. Maybe this is what dark matter is made of. I have a feeling we might be seeing some papers about this soon. But let's not get carried away. There are a lot of things that are mathematically possible which we don't observe in nature for no particular reason. For example, it's mathematically totally possible to have particles with spin 17.5, but we've never seen one in reality. It's like nature is a really exclusive nightclub where they don't let in anything too exotic. Sorry, spin 17.5, you're not on the list. Maybe try the universe next door. The paraparticles are also there. Every time I hear a politician talk about AI, I have this cognitive dissonance, and I finally realized why. They totally misunderstand what's going to happen. I realized this last week when I was listening to the British Prime Minister Keir Starmer announce his new AI initiative.
This is the global race of our lives. Now, some countries are going to make AI breakthroughs and export them. Others will end up buying those breakthroughs and importing them. The question is, which of those will Britain be? AI maker or AI taker? Put simply, our message to those at the frontier of AI capabilities is this: we want to be the best state partner for you anywhere in the world.
Or this speech by the President of the European Commission, Ursula von der Leyen.
AI can boost productivity at unprecedented speed. First movers will be rewarded, and the global race is already on, without any question. Our future competitiveness depends on AI adoption in our daily businesses. And Europe must up its game and show the way to responsible use of AI.
Or President Biden.
AI has the power to reshape economies, governments, national security, entire societies. And it must be the United States and our closest allies that lead the way.
Starmer thinks he needs more AI startups in his country. Von der Leyen wants European companies to adopt AI faster. And Biden thinks that America is leading the way on AI. And they're all totally missing the point. Who's leading is not America. It's some companies registered in America who are in possession of the currently biggest AI models, the so-called frontier models like OpenAI's GPT, Musk's Grok, or Meta's Llama. But these models are not the property of America. They're the property of some very rich people who are developing systems that in a few years will be more intelligent than everything and everybody else on the planet. The mistake that all these politicians make is to think of AI as a race for profit or prosperity. But this is much rawer. It's a race for power. Whoever will be first in possession of AI with superhuman intelligence will rule the world. And at that point, it won't matter where the company is registered, because they'll have multiple backups elsewhere to avoid a forced nationalization. Because once governments realize that they're no longer in control, that's what they'll try. But by then, it'll be too late. Those small startups that the UK and the EU are pouring money into have no chance to catch up with the frontier models. We already see this now, that most of the small apps are instead being built using the frontier models. So all that money that Starmer and von der Leyen are handing out will just reinforce the power of the frontier models. There might be a few niche applications where this won't happen, all right, but this will happen for almost all of the apps. Why? Because A, it's easier, and that means it's B, cheaper, and C, it'll be more user-friendly in the long run. A good way to think about the frontier models is as a new operating system. Technically, it's not what they are, but practically, it's how we'll use them. You'll sign up to one of them and use that AI to do everything on your devices. You'll use AI to write your emails, pay your bills, and procrastinate better than ever before. And for governments and other companies, that'll become indispensable quickly. If they don't sign up, they won't be able to compete. They'll need access for their financial management, military strategies, policy evaluations, everything. Not having AI access in 5 years will be like giving up on the internet today. And who will control that access? The people who own the companies. If you find that hard to believe, have a guess at which AI company made the biggest profit increase in the past year. It wasn't Google, it wasn't Meta, it was Palantir.
The Turing test is you have a computer that can convince you that it's a human being.
Palantir is a company owned by Peter Thiel. They provide multimodal AI solutions for data integration and management for large companies and institutions. They did, for example, win a contract to overhaul the data management system of the British National Health Service. But they almost certainly also have their hands in a lot of intelligence and military organizations. The name Palantir, by the way, comes from the Lord of the Rings trilogy, where the 7 Palantir are seeing stones through which you can watch other people. Hey, at least Thiel doesn't leave us guessing about his plans. And this is what the AI race is about. It's about world domination. Why is Elon suing OpenAI and building his own AI if he doesn't need the money and has enough on his hands already? It's because he wants to rule the world. What sense does it make that Sam Altman, the CEO of OpenAI, declares both that super intelligent AI is going to be super dangerous and that the only way to find out how dangerous it is to actually build it? If it's so dangerous, why doesn't he worry? Because he'll be the one in power. The rest of us will be living in the metaverse, mining Bitcoin to pay his energy bills. Now, let me return to those politicians. The only government that understands that this is a fight for world dominance seems to be China. The Europeans and Americans both fail to see the enormous concentration of power that's about to happen in the next few years in just a few companies. If I was the Queen of Europe, I'd take the money which was earmarked for that bigger particle collider, a few dozen $1 billion or so, and instead pour it into a publicly owned frontier model like yesterday. Because otherwise, Europe will be in even bigger trouble 5 years down the line than it is now. Though if I was the Queen of Europe, that'd be trouble enough already. I got some questions about an article that recently appeared in New Scientist, according to which some physicists found a way to quash the idea of the multiverse. I was super impressed because I thought that was impossible, so of course I had a look. The reason I think it's impossible to quash or rule out or otherwise question the idea of a multiverse is that it's not a scientific theory. If there are universes other than our own, they're unobservable. We can't ever either confirm or falsify their existence. The New Scientist article is about a specific type of multiverse, that's the many worlds interpretation of quantum mechanics. This interpretation has it that every possible outcome of a quantum measurement happens in its own universe. Just so happens that we only ever observe one. New Scientist reports on a paper which claims to solve a problem in quantum mechanics that goes like this. Suppose you have one quantum of light, one photon, and you send that through a beam splitter. The photon is then in a superposition of left and right, let's say in equal parts. According to standard quantum mechanics, before you make a measurement, the photon is in both places at once. But if you measure it, then half of the time you find it left, half the time right. The problem is that this process must conserve momentum because it's a holy law of physics. Without it, the universe would quite literally fall apart. In the case of this photon, the momentum is just an arrow pointing into the direction that the photon travels. You see the problem now. The photon goes in that direction, but if you measure it here, it's going in that direction or that direction. Momentum can't be conserved. This shouldn't happen. The authors in the paper now claim that the standard way quantum mechanics deals with this problem is to say that what conservation laws mean is that if we repeat measurements on a statistical ensemble of identically prepared systems, we get the same statistical distribution. In other words, they think that in quantum mechanics, conservation laws are merely fulfilled on average in many repetitions rather than in every single measurement. They say in the paper that the issue does not occur at the level of the many worlds interpretation because if you take together all those many worlds, then each single run of the experiment is the average. You never have an issue with conservation laws in the entire multiverse, just apparently so in one universe. Their paper is then dedicated to solving this problem of conservation laws in only one universe. And this, they claim, removes the motivation for the many worlds theory. In New Scientist, the lead author is quoted as saying, "We've essentially demolished one of the arguments for it. This is nonsense." First, I've never heard anyone make this argument for the many worlds interpretation, so they're demolishing a straw man. But worse, the problem that they claim to solve doesn't exist. Conserved quantities are always conserved in total in every single run, in every experiment in quantum mechanics, not just on average. In the case of the beam splitter, this is because of the photon goes through the splitter. It, strictly speaking, doesn't just create a superposition of left and right. It creates a superposition of the photon with momentum going left and the beam splitter moving a tiny bit right, plus the photon going right. The momentum is conserved for each case separately because the beam splitter also moves. It's just that the motion of the beam splitter usually can't be measured, so we don't bother writing it down. We know that total conservation laws are fulfilled in each instance of an experiment because, strictly speaking, all interactions would have to be described by the standard model of particle physics, and that has conservation laws built in. If your quantum maths violates them, you did something wrong. How do they solve the problem in the paper? By inventing an additional carrier for the conserved quantities that they call the preparer. They introduced this so that the conservation law is fulfilled at each interaction. And that is right, but this is what always happens. By the way, this video comes with a quiz that lets you check how much you remember. Here is the interesting thing though. Quantum mechanics does have a problem with conservation laws. Let's look again at the beam splitter example. As I said, the total momentum is conserved, but it isn't locally conserved when you make a measurement. Because before the measurement, you have half the momentum of the photon there and half here. After that, it suddenly jumps to only one side. The total momentum is the same in both cases, but the change is non-local, and that isn't compatible with Einstein's theory of general relativity. The only way you can solve this problem is to violate measurement independence. That's what's sometimes called superdeterminism. It's provably, by Bell's theorem, the only way to fulfill local conservation laws in a measurement process. This is so obvious, and all I can do is repeat this, hoping that eventually one day they'll understand it. But if that day comes, we can then say that science progresses one YouTube video at a time and you made it happen, so don't forget to subscribe. I've come to think of videos like this as my broccoli videos. It's the stuff that's on your plate that you know you should eat because they say it's healthy, but if you're being honest, it's not what your heart desires. Today's piece of broccoli is this. Every day we're inching closer to a new ice age in Europe because of the collapse of an ocean circulation that's keeping us warm. There are now multiple lines of new evidence saying that this is closer than we expected. Yes, I'm talking about the Atlantic Meridional Overturning Circulation, AMOC for short. That's a current in the Atlantic Ocean which transports warm water from the equator towards the poles. This keeps the water in the North Atlantic warm, and that warms up the air. It's the major reason why temperatures in Middle and Northern Europe are so mild. If the AMOC were to stop, temperatures in this part of the world would significantly drop up to 5 or even 10 degrees Celsius on average. In case you quite like the idea that my mouth will freeze shut, it's not a solely European problem. It'll globally shift precipitation patterns, leading, among other things, to higher temperatures near the equator and more rain in Australia. Probably because no one really knows what would happen. What we do know is that a lot of plants and animals would suddenly find themselves in the wrong climate zones. How high is the risk? Well, in its latest report on the matter, the IPCC concluded that the AMOC will very likely weaken over the 21st century with high confidence, although a collapse is very unlikely with medium confidence. I don't know what that means either, but I believe it means that the average probability for the collapse is small, say 10%, but it has a large spread, so it could be anything between 0 and 50% or such. I wish they would just write down numbers rather than this word salad. In any case, that was in 2019, and since then evidence has piled up that not all is well with the AMOC. One piece of evidence comes from a 2023 paper that looked at temperature fluctuations in the Atlantic Ocean. The idea is that if the AMOC gets closer to collapsing, deviations from the average temperature get more extreme and they show correlations between each other. This is a general behavior of systems near a critical point, which has also been observed, for example, in stock markets close to a crash or in Bose-Einstein condensates near the critical temperature, and so on. Fascinating stuff. In any case, the authors find that the AMOC is getting nearer to its critical point, and they estimate a collapse of the AMOC to occur around mid-century under the current scenario of future emissions. Another line of evidence is to check whether the conditions for a healthy AMOC are fulfilled. Spoiler alert, they aren't. The AMOC only works if the surface water in the north has a high enough salt content. If the salt content is too low, the water isn't heavy enough to sink down and close the AMOC circulation. But most of the ice in the Arctic and Greenland came from rain or snow. It's fresh water. Now that it's melting, it dilutes the salt content of the water. That makes the AMOC less efficient. The salt content of the water is measurable and we know it's dropping. A paper that appeared last year says that the climate models which the IPCC used for its risk assessment of the AMOC collapse don't take this into account properly. And finally, a recent reassessment of the AMOC collapse predictions that, I have to warn you, has not yet been peer-reviewed, found that, quote, the circulation collapses in all IPCC class climate models in the high emission scenarios and even in some moderate and low scenarios, despite the neglect of increasing Greenland meltwater influx. In most cases, the collapse is initiated by a breakdown of deep convection already early in this century. We conclude that a collapse of the AMOC can't be considered a low probability event anymore. What'd happen if the AMOC shuts down? It'd move the flow of warm water and warm air further south. This'd mean more cold air in Middle and Northern Europe and more heat waves in Southern Europe. The full consequences would need decades to play out, but the models predict that temperatures in Northern Europe could drop as much as 10 degrees on average. Somewhat coincidentally, Germany is about in a range where the temperature drop from the AMOC collapse might just about average out with the expected 3 to 5 degree increase from climate change. However, this is just the average. We'd probably get more cold and heat extremes. It doesn't average out, just like if you get punched in the head from both sides at once, that doesn't average out to no punch. What all this means is that Europe is inching closer to a new ice age with every ton of carbon dioxide that we pump into the air. Yes, I'm taking some creative freedom with the word ice age, which is normally used to refer to a global event and not a regional one. But I think it's an apt description. And also, you see, it's always good to give other people an opportunity to complain. It keeps the blood flowing. Thanks for watching. See you tomorrow.